Hello, my name is Michael Haskins.
And my name is Zachary Bodyfelt, and we will be showcasing the 4 focus sequences offered in UCSD's structural engineering program.
First up is the civil structures focus sequence.
As the name suggests, civil means structures that are going to be used by civilians in everyday life, and therefore shows students how to approach, design, and analyze civil structures. This includes a wide array of needs, including bridges, buildings, walls, and more.
There's a particular focus on steel and concrete since they are fundamental materials. It is pivotal to understand how forces are distributed and engineers are present to calculate them. Other aspects of civil structures can include transportation, hydraulics, construction management, and seismic design. Each of these branches have both a structural and non-structural side.
Since this focus sequence is the most broad, a plethora of jobs and internships are available, and thus different career paths can include structural design, where you work hand to hand to bring about an architect's vision, forensics, where you inspect how things were designed, what failed, and where the deficiencies occurred, and how to improve building codes so it doesn't repeat, and retrofitting to improve the strength of aging structures.
Second is the geotechnical engineering, which focuses on Earth's materials and how they have adapted with humanity.
Some of the most common structures developed in the sequence include foundations, tunnels, landfills, dams, retaining walls, pavements, and slopes. However, problems do arise, considering the majority of natural materials aren't seen by the human eye, and therefore their behavior is to be predicted from data and educated decisions drawn from limited data.
There is a particular focus on soil and rocks since they are fundamental to the structures and the erosion faced by them. Different soils and properties within a lab and out in the field and past loading histories are all variables that have to be accounted for. At UCSD, students have access to soil structure, interaction pits, shaking tables, and more devices that provide simulations of real-life scenarios.
Geotechnical engineering is also a broad field, as there are internships with local firms and an International Geo Institute graduate student organization. Third is the aerospace structures focus sequence, which uses computational optimization and advanced analysis methods in order to design aircrafts, launch orbital vehicles like satellites, manufacture marine vehicles, and sporting equipment, to name a few.
It has a particular focus on aircraft such as planes and UAVs, which are unmanned aerial vehicles known as drones for civilian or military use. Students learn about all the components, parts, and uniquely crafted materials that allow them to fly and have long-term projects that include creating these parts and analyzing them through testing and calculations.
And aerospace structures heavily focus on being lightweight, high in stiffness and strength, for maximizing performance through the development and research in advanced composite materials. Aerospace structural engineers commonly use forces such as thrust, drag force, weight, and lift to have to get appropriate ratios to get a structure to fly.
A key takeaway from this is aerospace structures are constantly evolving composite materials to find a path to make materials less expensive. Finally, graduated UCSD SE students are well known for going into mainstream aerospace companies such as NASA, Boeing, SpaceX, General Atomics, and the Navy. Last but not least is the structural health monitoring and non-destructive evaluation engineering focus sequence.
This pathway teaches students ways to protect structures against environmental damage such as natural disasters or man-made problems like war or pollution by detecting structural lifespan and whether or not damage will lead to severe problems through diagnosis.
This ultimately leads to improvements in designs and helps with routine maintenance across civil, geotechnical, automotive, aerospace, marine, and biological structures.
Avoiding failure benefits both humanity and the environment, and one way that is addressed is through the development of wireless sensors that determine modes and therefore can help address the damage before a catastrophic structural failure occurs.
NDE involves inspecting and evaluating materials without causing damage, while SHM deploy sensor networks that are not experimental and are full-time. Digital technologies such as 3D modeling and virtual simulations have created a new era of testing and data-driven analysis.
However, SHM and NDE are still limited to indirect damage detection, large form factor, high energy demands, complex data acquisition, and the requirements of physics-based models. Outside of UCSD, there are plenty of job positions from NDE and SHM engineers at many of the big companies already listed.
Finally, after evaluating all the different focus sequences offered at UCSD, I'm most interested in going into the civil structures, since from the beginning here I've always wanted to be a civil engineer, happen to be a structural engineer here, so civil structures makes the most sense for me. If not civil structures, it would be aerospace structures, but civil structures, I would like to be a part of making bridges and different buildings. Thank you.